Okay, in this video, we are going to look at another example of an application problem for pre-calculus, and this is for oblique triangles. So we're going to be using law of sines or cosines depending on the situation. So this is example 3 in our Unit 8 notes. And again, we have to draw the picture. That is the part that is going to cause just a little bit of stress, but it's okay. You can draw. So a boat race runs along a triangular course marked with buoys A, B, and C. The race starts with boats headed west for 3,000 meters. The other two sides of the course lie to the north of the first side, and their lengths are 1,200 meters and 2,500 meters. Draw a visual picture of the course and then find the bearings for the final two legs of the race. So basically what you have here is you have a boat that's racing here and here and here. Okay, that is what is happening. So we're going to create a triangle, a prettier triangle, with everything marked. All right, so we're told the boat heads west for 300 meters. So if you think about a compass, north, east, west, south, and west, that means it's headed left, basically, from our point of view. All right, so that means I'm going to have something like this, and I'm going to call this 3,000 meters. All right, then we're told that the other two sides lie to the north, so that means the boat turns and it heads in a direction of in a different direction for 1,200 meters and then 2,500 meters. So we're just going to make that 1,200 and we're going to make that 2,500. All right, so 1,200 meters. And I just did it in the order it was given to me. That's the only reason I drew it this way. All right, so we've got a visual. So what we need to do is find the bearings for the final two legs of the race. Well, for this leg of the race right here, the first one we drew, we knew which direction it was headed. It was headed due west because that's what we were told in the problem. So what we're being asked is, we want to know what the bearing is right here, okay, from this point to this point, and we also want to know what the bearing is from this point to this point down here. So I'm going to go ahead and label my buoys as A, B, and C. Since the race started with A, I am just going to label it that way. It doesn't really matter how you label it. All right, so in order to do this, I'm going to need some angle measures. I'm going to need this angle measure right here, and I'm going to need this angle measure. Well, if you'll notice, this is an oblique triangle. That means it's not a right triangle, in which I know all three of the sides, but none of the angles. This is the perfect setup for the law of cosines. So I am going to just start with 2,500 because it's across from B, and that's one of the angles I need to know. So I am going to write side 2,500 squared equals 1,200 squared plus 3,000 squared minus 2 times 1,200 times 3,000 times the cosine of angle B. All right, now this is going to get tricky if you don't pay attention to all of your values. So when you're doing all of the math here, you're going to need to be patient and you're going to need to write everything out so you don't mess anything up. Now, those of you who are pretty comfortable with algebra, this is not going to be too stressful for you. And those of you who are comfortable using your calculator and are comfortable with the math, it's going to save you some time because writing all this stuff out takes a long time because there are lots of zeros. Okay, so we're going to square all of the values that need to be squared. Okay, and even I'm using my calculator just to make sure I don't forget any zeros. That's totally okay. 2 times 1200 times 3000 gives me a really big number. Okay, that's exhausting. All right, so remember, these are like terms because they are constant, so I'm going to add them together. So see, I almost forgot a 0. Okay, now remember we have to subtract this from both sides. And that ends up giving me, should be a negative. And it is. You're supposed to get a negative here. See how that's negative? You need to be dividing by a negative to change it to a positive. So if you don't get a negative when you subtract over here, you've done something horribly wrong. Okay. All right. We're getting so close. And now we're going to divide both sides by negative this huge number, 7,000 or 7,200,000. Okay. Once we get there, this should, what I'm about to do should make your life blissfully easy. See those zeros? They can just go away. And then 419 divided by 720, a negative divided by a negative is a positive. So then, of course, in my calculator, what I'm going to do is type in cosine inverse of 419 divided by 720, and what you get for angle B is approximately 54 degrees. Okay, I didn't switch to the calculator, but just trust me. Okay, so 54 degrees right here. All right, so one's down. Now we just need the other one. So we are going to try for the other angle. Now, because this is a little lengthy and messy, all right, I'm going to make my next problem for law of cosine, I'm going to chop it up a lot. So I'm not going to write it all out. I am going to use the law of cosines again because I want you to see it in action once again. So now I'm going to use it to find angle C. Well, the side across from angle C is 3,000. So I'm going to start with 3,000 squared equals 1,200 squared plus 2,500 squared minus 2 times 1,200 times 2,500 times the cosine of C this time. Okay, so I'm going to do the same thing I did in the last problem. I'm going to square this, I'm going to square these and add them together. I'm going to multiply that together and divide just like I did before. So this is going to be a little bit more truncated. The next step I'm going to show you shows this squared, and then I've already subtracted this right here. So the result of that is this right here, and then multiplying all of this out gives me this right here. Okay, and then I am going to divide both sides by this right here. I know I told you you had to have a negative before. I'm sorry, I don't know why I said that. Did I get enough zeros? Ugh, too many zeros. I should never make these videos when I'm tired. Sorry, kids. Okay, so all of those go away. So I'm going to type into my calculator cosine inverse of 131 divided by negative 600, and that's going to give me, for C, approximately, let's see, I've got my calculator out, so Let's see what that's going to be. Okay, you get 103 degrees. All right, so I've got 103 degrees for this right here. And yes, we're not even close to finished yet. I know some of you are exhausted. It's okay, it's okay, it's fine. All right, so we do need to look at a few things in order to get our bearings. Did you like that? I thought it was funny. Okay, so the easiest way to do this is to look at this first one for angle B right here. It's the easiest one. Okay, so I've got 54 degrees right here. That means this angle right here is 90 minus 54, which would make it 36. So your bearing at B is going to be, you can write it one of two ways. You can write it as north, 36 degrees in the east direction, or you can just write it as 36 because it starts north. Okay, so that is our first bearing. Excellent. The next bearing is going to be a little trickier because I need to know from C to A what the bearing is going to be. So I can either have a south this many degrees east, or I can start here and go all the way around to right there. Okay, so that's where we are with that. So let me erase all this so you can see what's going on. All right, so here we've got our XY coordinate plane here, just drawn in, and this is C. Okay, what we have to do is we have to use our rules for parallel lines again, just like we did on that other problem. So this now is going to be 54 degrees because these are alternate interior angles. And that means that this angle right here is going to be 90 minus 54. So that angle right there is going to be 36. And then we're going to subtract that from 103. And that means that this angle is 67. So you just kind of have to work your way around to figure out what all of these angles are. So from C going to A, that bearing is going to be along this blue line right here. So if we use a directional bearing, that means at C going to A is going to be south 67 degrees to the east, or another way to think about it is starting north and going 90 degrees and then all the way through this right here. So, and that essentially all I'm doing is adding 90 to this little angle right here to 67. So what's this little angle right here? Well, if this one's 67, okay, what else do you need to get to 90? You need 23. So you're adding 90, 23, and 67 to give you a true bearing of 113. Let me add that and make sure I did that right. Use my calculator. Oh, I went too far. That's what's wrong with it. I was like, what is wrong with that? That's not right. Sorry, kids. Again, shouldn't make these videos when I'm tired. Okay, so you just need 90. You just need to the blue line. I don't know why I was adding so much stuff. So 90 to 23. I did it in my head and then I typed it in my calculator wrong. Go figure. Okay, so that is how you are going to write your bearings. Took us a long time to get there. So sorry.